Hi and welcome to this video in the MRDCL Understanding Concepts series, and in this video we're going to be looking at run control parameters. Now there's a lot of run control parameters in MRDCL and I can't think of a really good way of actually taking you through these without just going through the list and telling you what each one does. And I've missed one or two out that are fairly obscure, that are very rarely used, and sort of stuck to the main 20 or so, but this will be quite a long video going through what all of those do, but it'll give you some ideas about what MRDCL can do and what its run control parameters can do, more to the point. So first of all, what is a run control parameter? Well, it's the commands that you can put in between the start control and the finish control at the top of your script. Every MRDCL STP file must have a control stage, and there's a whole array of different controls you can put in there that control the whole run. So I'm going to go through them in alphabetical order, and where necessary I'm going to demonstrate in here exactly what they do and perhaps look at the output where that seems relevant. For some of the run control parameters I'm just going to tell you what they do and so that you can explore them further when you might need to use them. And we're going to just deal with them in alphabetical order because they don't really go into any sort of groups or clusters to make that any easier. So we're just going to work through them, and you'll find a PDF in the folder PRJ105 with this list, and you can obviously go into the help to find out more about them. So if you want to use the help, you can find out more. Let's look at the first one here, ADWRT, list topics, and it will come up and you can read a little bit more about it over and above perhaps what this video shows you. So let's start then going through this list, and the first one on the list is add tab. Now this is a run control parameter that means that when you run it, it's going to read the data in your data files and it's going to add the figures to your table. So let's imagine you have a set of tables from the previous month which had a base of 100 respondents, and there's your tables with 100 respondents in there. What you can do now is that you could run another set of tables with a different data file, or sorry, the same set of tables with another data file, and it will just add to the 100 respondents you've got in those tables already. So we could run with the current month's data using add tab, so it preserves the figures that it accumulated from the previous month, in my example of 100, add the current month, perhaps that's got 200 in it, and we should have tables now with a base of 300 as long as you add that run control parameter, add tab. So that's what add tab does. It's really mainly for very, very big projects where you're running the same tables every month. I can't think of another real reason for using it, but if you're handling really large volumes and you just want to add in some more records each month or each week or whatever it might be, add tab might be a solution. Add WRT, add write, is a similar option or similar run control parameter that allows you to add records to the end of an existing IDF. So every time you run a script, normally the IDF gets emptied and all the data is read. So if you've got a survey of 500 respondents, it will read the data and put 500 records to your IDF, or how many times you write to your IDF. If we have add write there, it will just add to the existing 500, so that if you ran it again with some more data, you might end up with 1200 records, for example, whereas without add write, it would just overwrite, delete the original data and just overwrite the IDF with the 500 records as you run them. So that's all add write does. Same principle as add tab, but it's just adding to the IDF. Now we go to a completely different sort of option, BRA. Now BRA will accept blank lines in a file as though they're a data record. Now sometimes a data file might contain blank lines, and by default MRDCL will ignore those blank lines as though they weren't there. So if you had let's say a file of 100 lines and 99 of them had something in it, normally MRDCL will ignore that one blank line in your file of 100 records, and so you'd end up with a base of 99. With BRA, it will read that record as a blank record. Now it's fairly rare that you want that, but it does have its uses occasionally. where you want to just ignore a blank, or sorry, shoot a blank line as an input record, even though it's got no data on it. BRP is the same sort of thing when you're punching data out. So normally when you punch a record out to a new file using the punch command, what you're going to get there is if it's a blank line, it won't bother punching that line out. With the run control parameter BRP, it will honour that blank line and punch it out for you to the file you selected. Now the next one we're going to cover is the C equals statement, which tells it where the data files are and what data file or files you want to read. And we're going to cover this one in a little bit more detail here. So I'm going to go to a script that we have and look at the C equals file, C equals here, and see what you can do. So the first thing to note is if we just say C equals data.ask, that means that my data is in the same folder as the STP file, and I want to read a file called data.ask. So if I run this script, you'll see up here it's read 831 records from my STP file, from my ASC file, and that's the number of people in my table. When I come to look at my tables, there's the 831 respondents. So that's one thing that you can do. You can just say, well, the data is in a file called data.asc and it's in the same folder. If it's in a different path, you could say what that path is. That works perfectly well. So if you've got your data on the Z drive, for example, you could say C equals Z : /data files data.ask, and it would find that path. And if you've got it by another referenced path, you could say ... /data. So that would mean ... would mean go up one level and then come back down a folder called data, and I want data.asc in that folder. And if you've just got one dot, that would mean you're in the current folder in a subdirectory of current folder called data. So that's the way you can specify paths in here. So that's the first thing that you can do. Now another thing you can do, if you have nothing in here, no C equals statement, what MRDCO will do if you execute, it will prompt you to find the data file, and you can just use browse to pick the data file. If it's the one in this folder, you can just click on that and it will prompt you for another data file. So it does still work without a C equals statement. As you can see there, I selected the file, said there wasn't a second file, and it continued. If you've got more than one file that you want to read, you can just string them along in a line. So I could say that my data is in data.ask, separate them by a semicolon, and then I can have a second data file, or indeed a third data file, and so on. So as many files as I want to in that list could be there. The last one doesn't have a semicolon after it, it just has a comma. So that will let me put a list in. And the same rules apply there about paths. So I can put in a path saying exactly where that data file is, and it will go off and find it down that particular path. Now another way of picking up a data file, if you want, you could use this notation, C equals less than greater than. So that will prompt me just like it did when I didn't have a C equals statement in there at all. So that's going to make no difference. But another thing I can do, I can have a file which is a text file. It hasn't got to have the TXT file extension, but it's just good practice. And in that I can list my data files one line at a time. So I could open up a file called datafilesnow.txt. You can give it any name you like, and in here, one per line, we can say what the data files are. So if we had two data files like that, that would be fine. Now that works very well, I think, if you've got a tracking study or a continuous survey where you want to put in each month's data one at a time. So as you add a month's data, you want to just add that to the list. And then MRDCO will just process that like one big file, one after the other, picking the files up. And that's a very tidy way of working. I haven't actually got that file here, so I can just save it with one file, which of course also works perfectly well. Save this, run it, and I've got exactly the same answers here because that's reading that list, and it found in that list data.asc. So that's another way of working. Now, the final way that you might want to work, and this is a slightly more complex area, which we're not going to cover here in any great detail, is you can have data in more than one file. So you could say that I want to read from data.asc and data2.asc. I want to read them as separate streams. So let's say for some reason you've output data from maybe some online software where the file has output one part of the data to a file called data.asc and another part of the data to data2.asc. You could use read statements to read from each of those two files to marry your data files together. If the two data files have the same records in them, you can just read one from each file and then merge that all together. There's quite a good blog article on our website if you do this, where you've got extremely large, long data records where it's perhaps too big to handle in one file and you want to output it as 2 or 3 files and then read each at the same time, from one record from each file and another record from each file and so on. But you can control that so that you can match one file up with another. So if you've got a file, let's say, of 200,000 customers in one file, but you've only surveyed 200 of them in another file, you could match them up on a serial number or some other identifier so that you could merge the data together by reading from one file of the master of 200,000 customers and emerging their survey data for the 200 you've surveyed from another file. But that's quite an advanced technique which we're not going to cover in this video. So that's the C = command. Now the next command that we're going to cover is one that I find very useful, and that's the steps that you want to run. So this is a command CEPX, so here it is on the list down here. Here it is, and these are the steps you want to have executed, and they can come in any of those combinations or any logical combinations. So if I put CEPX in my control stage, it means by default I want to compile, execute, print and export. Well, I've got nothing I'm going to export here, so I'm going to turn that off. But you can see what happens if I've got CEP in here. When I come to run this, you'll see that it's automatically defaulting to compile, executing and printing. Whereas if I'm going to put C = data.asc back in there for convenience. If I just put CE in there, it's only compiled and executed, and the only things that are checked when I come to run are the compile and execute. Now, I use this quite a lot when I'm building a project, so I just have the compile on when I'm actually setting up a project quite often, so that when I run, it's just got that set. Maybe there's no data existing, or I don't want to run the data, but it means by default I've only got compile, I run that, and that's all it does for me is compile. There's nothing to stop you choosing execute and print on top of that, so it actually does all the steps. It's just which steps it has defaulted in the list of options there. Now the next one I'm going to look at is another one that's got quite a few options attached to it. That's CSV2. Now what CSV2 does is give you a set of tables in a CSV file as well. So you don't just get the tables in a tables file, a text file, you get them in a CSV file as well. So if we run this, I can set that parameter off. I'm going to put EP back in here now. And now it's made my tables. If I go to the folder, you'll see there's a data tables.csv. And I've now got a tables file in the spreadsheet format here that match the TXT tables, mainly match them. You'll get this marker in column A which indicates what piece of data is in every row. So BE means begin, JH is a job header, footer, table number, title, column headers, and so on. So each of these letters has a meaning. The reason those letters are in there, if you don't want them, you can just delete them. So if these tables go to a client, you might delete them and hide that column. The reason they're in there is that if you wanted to build some automated process off the back of this, say you wanted to do a chart in Excel using a macro of all the rows, you might just pick off all of the RWs and use that data as the data to go into a chart, for example. So that's the reason that each row is marked with an indicator or marker saying what's in that particular row of the tables.csv. Now, the run control parameter CSV2 has some additional settings that you can make. So let's have a quick look at those. The first one is R, and what R does is it rounds the figures the same way as the text file. Now that can be quite important. Sometimes when you're doing PowerPoint presentations, people can get confused. The tables in a text format might say 22%, but when they're in an Excel chart or something like that, it might say they're 22.4, which might confuse people and make them wonder why the figures aren't exactly the same. Well, it's because of rounding. So if you want your figures and percentages rounded in the CSV file, you just put an R there and it will round them in exactly the same way. Another option, and you can add this onto the list if you want to, so you have R and M together, so you have CSV2RM. M on its own means that you want markers, and that's significance test markers, to appear as separate columns. And again, that might be for some post-process that you want to run, rather than as an extra row in the table. So that means you get a separate column with any significance test markers added. And the other one is an I, which gives you information. Now I'm going to run this because I think it's easier to explain what it is having run it. So here's I. Let's have a look at our tables now. And what this gives you is some information about the table that's coming out. So you'll get one of these information lines like this for every table that you produce. This run's only got one table, and in that information line you get some things about the table. And the reason for this is that it allows you to do some automation as well. So again, if you wanted to pick this information up, you could automate some reports from this, maybe in Excel. So this tells me that in the information line that it's table 1. It's got 8 rows in it. It's got 11 columns. The page number is 1. When it comes out, it'll actually have page 1 on it as well, because you can give it a false page number in MRDCL, or different page number. The type of table is a distribution table, and they're the format settings that we had set when we ran that table. So all that information is available if somebody wants to automate and know that they've got 8 rows coming out by 11 columns in this table. It allows you to build macros and do some automation. So that's what an information row is. And in the STP file, you can use R, M, and I in any combination. So that's perfectly valid as a run control parameter. All right, let's move on to some of the others now. I think we're going to do some a little bit faster now. The next one on the list is an export feature, and that allows you to export to automatically to different formats. Now this just really is a shortcut for the data menu. So rather than going data export, and there's a whole video on exporting data from MRDCL, you can just say export equals SPSS, for example. Let's just do that. And that will automatically not only carry out my run, but we'll find now that we've got an export to SPSS. Now I didn't actually run the export step there, which I needed to have done, so let's just quickly correct that and click on the export, and now it should run absolutely fine for me. And if I go into my Explorer, there you can see I've got my SPS files automatically generated without having to go through the data export menu. So that's worked absolutely fine. All right, let's move on to the next run control parameter in the list. The next one is header. I should say, by the way, with the export feature, you're also going to set some controls in that. If you want to use the export feature and start using DTV files, look at the help and it will tell you how to use the different parameters that you can set with an export run control parameter. The next one is a header. This is a very simple one. It just produces a header in here so that all the listing files get that header coming out when they produce their output. on to the next one. The next one I see means ignore data records that begin with this string. So sometimes in data files, some programs output things like a batch card or a batch record. So if you wanted to, you could ignore anything that had the word batch in it, for example. So if you wanted to do that, you could put ignore batch, and that would ignore any record that had the word batch in the first 5 characters, or begin. Sometimes a file can have a begin in it. Not very common, but quite useful when you have such things coming out. IDF equals is a way of saying that you want to run a set of tables, typically, where you're picking up an IDF that another script has produced. There is a video on splitting your script so that you have your data stage in one script and your tables in another one. IDF equals means that you want to do some tables, picking up data from an IDF you've already created. Info provides some more information at the screen when you run it, so let's quickly look at that. So here's the info one that we want to run. Let's put info in here. By the way, these run control parameters can come in any order that you like, it doesn't matter. There's no precedence or anything like that. And you can see when it runs, it just gives you an awful lot more information at the screen in terms of how many records it's processed and so on, bytes allocated, pages and so on. So it gives you a lot of information that you wouldn't normally get when it runs about the run that you just carried out. Most of that is self-explanatory. So I'm just going to take that one out. We don't want that. All right, let's go back to our list. So we come to the int ed run control parameter, and what this will do is that rather than listing statements, listing errors or anything else that you're outputting to a report file, int ed will direct it to the screen so that you can see any errors or things you're trying to flag at the screen. So that's what int ed does. It makes it come out of the screen rather than in a report file. Int print is something I find very useful. If you're rerunning a set of tables and you only want one table, now this is not going to be very easy to demonstrate here. Maybe I'll just increase this to a second table here. So let's run this, and I'm going to pick the run control parameter int print now. I'll put that into the run, sorry. There we go, so it's in there, we run it. We click on interactive print, and now what it will do is it will interactively say, well, what table do you want first? I could start with table 2, I could put it on page 33, click OK, and it will print that table for me. So that's an interactive print tool that you have. We're going to take that out. The next one is INX, and that produces an index file. So I think, again, I'm going to run that so you can see it. So there we are, it's done that. And you'll see we've got an index file here, and it tells me what table it's output. So it's output table 1 as ID 1 starting at page 1. And these are actually producing MRDCL commands that would work in a print stage, which is rarely used in MRDCL, but it's a way of getting script out so that you can generate your own print stage. Let's go back to the master list. So we're down now to ITF equals. So ITF is where you want to hand over tables to another stage, and this happens in 2 scenarios typically. One is where you want to add more tables, so you want to pull in a set of tables and add some more tables to it. Or you might want to just manipulate some tables. So if you've got a very, very big manip stage, you might want to read the tables that you've calculated, and then in a separate run, use ITF equals to pull in those tables and manipulate them to do whatever calculations you want to do on the tables in manip. So it has 2 purposes where you want to sort of build on the tables you've already got. The third purpose it has is a slightly different one. It's where you want to feed a table back into a data stage so that you can pick that up as a reference. So This is sometimes used where target weighting's been calculated in another run. I've seen it used as a lookup for storing mileages of different journeys. So you might have a matrix of all the airports in a country or in Europe, and that would be just a table of the same places by themselves. And then if you knew someone boarded a plane in London and got off the plane in Rome, you could look that up in a lookup table stored in MRDCL to see the distance that they travelled or how many points or air miles they got for that journey. So that's another use of ITFs. Max IDF limits the number of records that you read from an IDF. So you might have 100,000 records on your IDF, but perhaps you want to test your tables on just 100 records, and so it will just read the first 100 records for you. The next option, min show, that will limit the number of data records to be seen. Now, what that means is that it does a couple of things for you. If the base is less than the number shown there, so if you set min show equal to 50, say, it will hide any columns in your tables where the base is less than the number that you set it to. It will also work when you export data, that it will prevent data being exported and listed, and that carries over into products like Reflect and Resolve. That if you have min show, it will stop people showing small bases, and it's basically there to protect small sample sizes where people might be identifiable from being a small base in a table. So perhaps you've got a department where there's only 10 employees and only 2 of the employees answered the survey, so their answers would be quite identifiable if they were to appear in tables or listed out or used for exporting. The next one we got is no add any. What this does is it stops the run being added to the list of runs that you've got available. So when you open up a list, these are all the runs that I performed most recently. If you don't want the run you're currently running to be added to that list, you can put in the run control parameter no add any, and it won't appear there. No dis redirects interactive output to the report file. So this is the opposite of intet. So when you use the commands like hold that hold information at the screen so that you can edit it or show information that's in the data under any conditions you choose. If you'd prefer to change that so it puts it to report file, obviously, in other words, the opposite of inted, no dis will do just that. No list will suppress the printing or the creation of a listing file. So if you've got a run that you know is working, it's quite common to use no list as a run control parameter so that it doesn't waste time making a big listing file. That's particularly important on big projects. It will save some run times. If you just want to not list parts of the script to the listing file, there is a format option that will also work in a similar way. No lsum means that it suppresses the list summary from the report file, so that when you get a summary of errors and listings, they will be suppressed if you have no lsum. No print ITF, what that will do, we talked about ITF equals when you pull tables through for another run. Typically when you do that, it will pull through any tables and print them with any other tables that you add to the tables file that you generate. If you go no print ITF in the control stage, it won't print the tables that were on the ITF, only the new tables in your particular script at the moment. No RPT means that it suppresses the report file, so that won't come out at all. No tab will mean that the tables file is suppressed. Now, that's one that's quite commonly used when you only want the CSV output, so you don't want the program to waste its time building tables in a text format. You just want the CSV file of the tables, so no tab will do just what you want there. O equals will redirect output files for you, so your listing file and your tables file can appear as a different name. So although I'm running a run here called data.stp, if I set in here that I want O equal to my run, all of my output files will now come out as my run. And if we go into the folder now, you'll see I've got my run listing.txt, my run report, my run tables, and my run index, and so on. So that's a way of redirecting. Now that's quite useful if you're running a run perhaps monthly, or you don't want to overwrite the previous files, or you want to run it with various parameters that drive it. And it's certainly a good tool to use if you use the batch system that's available in MRDCL to do a number of runs. So say you're running a set of tables for 10 different countries and want 10 sets of tables. With a batch run, you can automate it so that it will output each set of tables to a different file without overwriting. Again, you can have a path in there, and again you can prompt for O equals less than greater than, and it will prompt at the screen for the name that you want. So that's O equals. Let's go back to our list. Old names, what that will do is it will shorten the names of the output files. So by default, for example, a listing file comes out as the run file name listing.txt. With old names, it will come out as data.lst. Report would come out as data.rpt with old names, and the tables would come out as data.tab. You're really advised not to use that. There is a particular occasion where you'll get a conflict and you could accidentally overwrite something. You do have the ability to list to a CSV file key bits of your data or various variables from your data file. And if you used old names with a list CSV statement, they would both try to write to the CSV file, and the last one to run would overwrite the other. So that's a situation where you'd have to be very careful, and I wouldn't recommend. I don't recommend using old names. Old WQ means that quantity weighting is applied as it was in the older versions. What that means is that in the very old versions of MRDCL, the select WQ statement used to weight the unweighted row as well as the rated row. Well, now with old WQ, it will do that. By default, it won't weight the unweighted row. PPX equals N, so that's a way to set indices in here. So in here, I could say something like PP value equals, which we go for 6, and I could replace this 6 down here with value, because what it's going to do for me is it's going to give the PP command, or the index value, the value 6, and it'll replace that with a 6 for me when it runs. Now that's not a very good example of when I would use it, but you can see it's doing everything I want here, and if we go to the listing file, it will just say 6-6, replacing that as I chose. Now it's more common to use that, I think. I'm going to set that back to what it was originally. Another way of using this is to prompt you for a value, so that as it runs, it will ask you what value you want to give the index value, and then that can affect what happens in the run further down. This is more commonly used where you've got a script that's used for multiple runs that are similar. So say you've got a country survey where you've got 3 countries and there's 2 versions of the questionnaire, and you might want to set the value for the country so that it picked up something slightly different. So something like list the region might be different for country 1 it is from country 2, and so on. So you could skip round that piece of code depending on whether you're running country 1, 2 or 3. So it's a very good way of keeping everything in one run, rather than copying the runs and having a run for each country or for each time period, or whatever it is that's different about your multiple runs. PP only is a run control parameter that will just expand your code to a PPP file. So if we look at that, I'm going to put PP only in here. I'm going to take that out. So this doesn't actually run anything at all. It just makes a PPP file with everything in it. So if I now look at my output file here, you'll see I've got a file called data output.txt, and that's got my PP only in it with my script in the long form. So it's a way of creating a script and just being able to see what it would generate if it carried on to run. So you could check, for example, that your preprocessor code is working as you would hope. P equals allows you to punch out. Now this works exactly the same as a C equals, except you can't have a list of files in a name there. But you can say PA, PB, so punching out to file A and file A using punch A and punch B commands. So it's a similar sort of tool there to the C equals command, but just for punching out one particular file or to more than one file. Terse means it just minimises the information that comes out of the screen, so we're not going to look at that, but it will just minimise the amount of information that comes out of the screen when it runs. Tidy means that your K file that holds your internal MRDCL file, so that you don't have to rebuild it if you rerun it for any reason, are not created. So everything, all the internal MRDCL files are kept temporary. Undefined means that it sets the format option IFF to U automatically for you, so that any field is set to U rather than not read as 0, which is the default where you find a blank field, for example. The next run control parameter, Unicode, means that you can have your tables or other files output as a Unicode text. And indeed, you can read insert files as Unicode as well with that particular setting. X.temp overrides the fact that by default, MRDCL will treat any variable that begins with an X as a temporary variable and not write it to the IDF. So if you've got any building block variables, they don't appear on the IDF and can't be used in tabulation, but they're then hidden from any exports and also make the IDF smaller. So if you've got some complex building blocks or big variables that you don't really need, they're just being used for building more complex variables, put an X on the front and they don't get written to the IDF and make your projects run faster. However, this run control parameter X.temp means that X is just like any other variable and can be used in the table stage and will be written to the IDF. And finally, xref gives you some extra tools in the listing file. This is mainly for debugging when anything goes wrong, and it's something you probably won't use yourself, but we might request if you're sending us files for debugging. So I'm just going to override this and run it again, and if we look in the listing file now, you'll see there's some numbers here referencing what we got in this file, and they're diagnostic tools, so at the bottom we can see what is happening as everything is read in. So these are addresses in the system, and it's telling anyone who's debugging what's going on with all these variables and how they're being pulled together. But it really is for developers to use rather than for somebody who's typically using MRDCL. Well, there we are. We've just got one more left. We've got xtabml, and what that does, it will produce an XML version of your table, so that again you can write a program that could read the tables in an XML format. xtabml. So we run that, and we should have an XML version of the tables here. Here they are. And so we've got the tables in an XML representation, and somebody could write a program that read that XML code and interpreted it for some other piece of software or for some other reporting type of task. And there's the file in XML format that could be read by another program. So we've got to the end of our list. This has missed out one or two of the run control parameters, but they're fairly rarely used. There is always more help in the help with these things. If you really get stuck, obviously our support would help with these things, but it just shows you the range of different things that you can do with your runs to deal with some special circumstances that can make runs a lot quicker. Thank you for joining me on this video. I hope it was helpful to you.